Hi, so today we are here naming ionic compounds, and the case that we're looking at is when we have metals with multiple charges. And I've taken a snapshot right out of my textbook here, showing you that we have quite a few metals that have more than one possible charge. And for the most part, this happens when we are outside of the main group elements, so you see that most of these actually fall right here within the transition metals. So let me show you why this becomes a problem when we go to assigning unambiguous or unique names. There are two possible compounds that iron can make with oxygen, and based on what we know so far, we would name this iron because I see the cation is iron, and I would name it oxide because I see the anion is oxygen. Well, iron oxide could describe this. It could describe this. I don't know which one, and so therefore I need some unambiguous way to name these. So we're going to look at how we do that. So in these compounds, a good first step is to find the element that's in the main group. In this case, that's oxygen, and that's going to give us a predictable charge, because if you recall, we want to go from a formula to ions and then be able to name it. So we've got our formula. We know oxygen is in group 6A, and ions in group 6A have a 2 negative charge. Now, if oxygen is 2 negative, that means that my iron here, to make this electrically neutral, has to be iron 2+. So now I've got my ions, and I'm ready to name this iron oxide, but the piece I use to tell me which iron I have is I'm going to put parentheses with a Roman numeral of 2 following the iron. Over here, I could also take my subscripts and crisscross them up to get the charges. Iron 3+. So you see here I have iron 2+, and over here I have iron 3+. That's why my formulas ended up looking different. So what does that mean for my name? Well, it means it's still iron, but it's not iron 2, it's iron 3, and then oxide again. Remember, it's ionic, so we never use any prefixes, but we do use those Roman numerals. So there is one more naming convention. The one we've looked at so far is the systematic way of naming, and the other is older, and it's called the common names. The rule is that the ion with the lower charge, in this case for iron, that's 2+, ends in us, and the higher charge ends in ic. And for iron, that's 3+. And so then we go to the Latin names of the metals, and your instructor will tell you how many of these you need to memorize. You can find them in your textbook. But this would be ferrous oxide. Again, this is the common naming. You'll sometimes see it on food labels. And this over here with the higher charge would be ferric oxide. Again, unique names for both of them so that I know which iron oxide compound I'm talking about. So let's just look at two more quick examples. A key on these problems is to recognize when you've got one of those metals that has the multiple oxidation states. Copper, for example, is a very common one, so you should know copper. I'm going to need the special naming with the Roman numerals or the ic and the us. So looking here at copper chloride over here, if I want to figure out from the formula to the name, then I need to stop with the ions. So I'm going to find the main group element that I'm sure of. That's Cl- because it's in group 7A. And if that's negative, then to make this electrically neutral, I need to have copper+. Then I have to have memorized that copper+ is the lower oxidation state, or just use the systematic way of naming this. So that would be copper 1 chloride. No space between the copper and the Roman numeral 1, or because it's the lower oxidation state, cuprous chloride, either one of those being a correct answer. And then cupric oxide over here, I would have to remember, okay, cupric is copper, ic is the higher of the two oxidation states, oxide 2-. I noticed that 2+ and 2- are equal, so my formula would be CuO. Hopefully that helps with your transition metals and multiple oxidation states on your metals, and thanks for watching.